Hello friends, in this video I'd like to solve the following problem from the Romanian District Mathematical Olympiad for 12th graders 2011, problem number 1. We wish to prove that the following 1 over pi times the integral from sine of pi over 13 to cosine of pi over 13 of 1 minus x squared dx, this number is rational. So actually we will compute this integral, and here are my hints. First, try to compute the indefinite integral, the antiderivative, in other words, dx is missing, no, it isn't, by the following substitution: x equals sine of t, where t, let's say t is from minus pi over 2 to pi over 2. And then the following two identities may be useful. Arc cosine of x plus arc sine of x is always pi over 2. You can verify it easily, either considering the right triangle of some sort or by differentiation. And well-known identity, cosine squared of t plus sine squared of t equals 1 for any real number t. So give this problem a try. Right, so let's start with the indefinite integral of 1 minus x squared dx. Well, to compute this, I will do the following substitution. I will put x to be sine of t, then dx becomes cosine of t dt. And also, I will consider only t between minus pi over 2 and pi over 2. Well, why is that? Because we see that x must be between minus 1 and 1, and sine attains every value between minus 1 and 1 for t from this interval. And after this substitution, our integral becomes square root of 1 minus sine squared of t times cosine of t dt. Right? And now here we have square root of cosine squared of t times cosine of t dt. And this is, and now you see why I have chosen this constraint, because on this interval cosine is non-negative, so I can get rid of a square root and I have just cosine squared of t dt. Right, now I will use well-known formula for cosine of double the angle, or rather that it can be written in this way. Well, why is that again? Because of this well-known formula. Cosine of 2 times t is 2 cosine squared of t minus 1. So after finding cosine squared, you will get what I have written right here. And now it's elementary integral. It's t over 2 plus 1/4 sine of 2 times t. Of course, plus some constant. And now I wish to go back to x, but maybe I will do the following. Notice that sine of 2 times t, another well-known formula, sine of 2 times t is 2 sine of t cosine of t, but cosine of t can be written as 1 minus sine squared of t. Alright, so I will have plus 1/2, because here we have 2, so we have plus 1/2 sine of t square root of 1 minus sine squared of t plus some constant. And now let's go back to our x world. Recall that x equals sine of t. That means that t equals arcsine of x. So this indefinite integral is 1/2 arc sine of x plus x square root of 1 minus x squared. Let's see. And maybe it's so important that I will write it again right here in violet. This equals 1/2 x 1 minus x squared plus arc sine of x plus some constant. And we will use it. By the way, if you are preparing for some exam or some Olympiad where integrals are required, I suggest that you remember this very integral, because this quantity 1 minus x squared under square root appears quite often. Alright, and now we just wish to compute 1 over pi, or maybe, you know what, let's get rid of 1 over pi, integral from sine of pi over 13 to cosine of pi over 13, 1 minus x squared dx. Right, so it's just 1/2 times our quantity evaluated from sine of pi over 13 to cosine of pi over 13. Which is, what exactly? It's 1/2, right? And here we have cosine of pi over 13 times square root of 1 minus cosine squared of pi over 13 plus arc sine of cosine of pi over 13 minus sine of pi over 13 square root of 1 minus sine squared of pi over 13 minus arc sine of pi over 13. Right. And now let's see. Since pi over 13 is clearly in the first quadrant, this entire thing can be replaced by sine of pi over 13. Likewise, this can be replaced by cosine of pi over 13. And if you look closely, this and that cancels, which is very helpful because it's the part which causes troubles. And we are left with 1/2 arc sine of cosine of pi over 13. And the second part, well, arc sine of sine is just the argument. Right. So it's 1/2. And now, what is arc sine of this number? Well, now this identity comes in handy, that arc sine of x plus arc cosine of x equals always pi over 2. Which means that I can replace arc sine of cosine by pi over 2 minus arc cosine of pi over 13. Which is good news, because arc cosine of cosine is just the argument. Alright, so it's 1/2. Now let's make a common denominator. Common denominator will be 26. So we have 13 pi over 26 minus 2 pi over 26 minus 2 pi over 26. So it's just 9 pi over 26. Over 52, because we are multiplying the denominator by 2. Which means that 1 over pi times our integral is 9 over 52, which is clearly a rational number, which actually closes this proof. It is a rational number. We have the exact result. So yes, thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.